So we're special section today for the missed class Monday and Wednesday. Also, I decided I was taking a look at the syllabus and decided we'll need one more as well. That'll also be recorded. So if you can't make it, um, that'll be online, but that'll be on the 30th, so a week from today. Same time, same place, and then obviously we're meeting on Monday and Wednesday of next week too. So next week there'll be 3 sessions. So yeah, that's about all I got for that. And then as far as where we're going from here, I do need to get the let's see, homework 2 needs to get assigned relatively soon here. So I'll probably have that while you're working on your labs today. I'll get that up there. I just need to do some tweaks before I get it up. It's about that time to get that out there. So, and then as far as what we're doing this week, and we'll continue this on. We're not going to get through the whole thing today, but we're going to start up on chapter 3, which is the classes, basically. So, all right, let's get this going here. Is this thing working? There we go. All right, so finally got a handy dandy little thing so I can not be trapped behind the desk the whole time. So, so we're going to do classes, objects, methods, parameters. This class, 256, we move a little bit slower than 232, which is the apps course, another programming course at the 200 level. But it's sort of methodical in its nature, and we want to take a really deep look at what it is that makes up a class and an object and a method and that kind of thing. The wrong way. Okay, so we're going to start out by creating a gradebook class. And that class we're going to use to create an object. And there's a difference, remember. There's this idea that you can have the blueprints of a class and then a class itself. And the class description, the .java file of the gradebook is going to be something like gradebook.java, for example. This is where we start talking about how there'll be a driver class, for example. I realize the people online aren't going to see this, but that's all right. So there'd be like a class book .java, and there'd be like a driver .java. This is the gradebook is what we call that. I'm sorry, gradebook. So this would be like the blueprint. Driver.java would be the objects, also known as the instances of the gradebook. So it's just like the analogies I've used before with cars and whatnot. It's like you can make a blueprint for a car without actually making the car, and then what you can do is you can take that blueprint and you can make a whole bunch of cars from it. Now, we also want to talk in this chapter about the access modifiers. If we have a public access modifier, it means that the class is available to the public, so everyone can use it. So the difference there is that a private modifier means that only the class that defines that has access to it. So what this allows you to do is when you're defining your data, you can make sure that you're the only one that has access to that data by using it as a private. If you want anyone to have access to it, you can make it a public. And that way, if like, for example, if I was just, I've got my contracting gig still going on with Boeing, and that's why I was missed a couple days there. I had to do a presentation out there, and one of the things we have going on is we have a bunch of programmers, and we're making different parts of the drone controller. And when I create my part, which is the recovery aspect of it, I want to be able to expose those recovery behaviors to other programmers. But there's underlying things that I shouldn't need to expose. Um, there's all kinds of parameters that need to get uploaded to the device, for example, to the aircraft. The users of that system, all they need to know is they have to access the public method that says recover the aircraft. They don't need to know like there's 20 different parameters that like, you know, configure the ailerons and all these various things that they do. But they don't need to know that. All they need to know is, okay, I want to recover it. And that's why you have this differentiation. So we make public available to the public. That means it can be called from any other classes. And so, you know, using that analogy or of the drone, you know, system that I was working on, anyone should be able to recover it. Anyone should be able to launch it. There's a set of things anyone should be able to do. The analogy for gradebook here would be there's a set of things that anyone using a gradebook should be able to do. They should be able to add students and add grades, you know, add assignments. The return types for the methods are basically like we're saying, we've called into a method, what do we want it to tell us about itself? If it succeeded or not might be a good thing, for example, like, or maybe we're going to query what the grade is, the final student grade is from the gradebook. A void would be a method that doesn't perform, doesn't actually give us anything back. It just does something. So like, for example, quite often if you add a student to a gradebook, that might be a void method that doesn't really have to return anything. Now maybe not. Maybe it would return a Boolean that would say whether or not it successfully added the student. It just kind of depends on the design. So the convention here is that the method name follows the return type. So you're going to have basically your so if we've got a method named add student, we'd have like public void add student. And I'm not going to do the rest for now, but there'd be some other stuff after this. Here what we're talking about is this is the access that we give it. So anyone can call add student. This is the return type. So in this case, it adds a student, but it doesn't return anything. Why is that? Like based on what we saw from chapter 2, why don't we need to add anything? Or I'm sorry, why don't we need to return anything to something like add student? Like what's add student really going to do? Yeah, it's going to create a record inside of that instance, that object of the class. So there's no need necessarily to return anything from that because it's doing something to itself. It's adding something to itself. Just like, you know, using our car analogy, if you're on an assembly, you got an assembly line making a car, there's going to be some procedure to add the chairs to the car. And that's what it's going to do. It's going to add the chairs to the car. Now, very well, there might be a thing that says, well, the manager wants to know if you successfully added the chair, and in that case, it has to return some value. It doesn't return the car because the car it already has. It just has to add the seat in there, and then you're good to go. So here we go. This is a public void display message. Here we're starting even a little more simple than the question I just asked about the add student, because add student implies a whole lot of other things. This one's really simple. It just does a display message and it just prints out to the screen. So it just dumps out this message that says welcome to the gradebook. Presumably this would be for like when you log into the gradebook for the first time. It would just spit out a message and it just says welcome to the gradebook. So this is a method called display message. It doesn't have to return anything because all it's supposed to do is print out to the screen. And it's public, so anyone can call it. And it just dumps out to the screen. Now here's the interesting part, one of the interesting parts. Class gradebook has to be used somewhere. It itself is not an application. It is just a blueprint. It is just the definition of a gradebook because it doesn't include main. So when you define the entry point for an application, you have to have a static void main in there, like we've seen before in chapters 2 and that kind of thing. If you actually define this class here, well, let me go back. If we define this, and that's all we do in Eclipse, it's going to give us an error message. It's going to say, no such method error main, right? Because it can't find where to enter. It hasn't created any objects. It just, that's the point I want to emphasize. When you say this is a blueprint basically. It does nothing on its own. It just sits here, and someone could call display message, but no one is right now. There's no code saying call display message. It's just stands on its own. You can compile it. It won't give you any errors, but it's not going to do anything. It's not until we get to a main method. So as we start making larger programs, we need to have a main method. Some people call this the driver class. That's why I'm calling it up on the board here, the driver class. So in our case, now we make a driver. Notice the difference here on line 4, public class gradebook test, right? And then over here, public class gradebook. So the class names are different. So what we've got over here is we've created a new class, but this time it has a main. And the main says gradebook, my gradebook equals new gradebook. So this part here, the new gradebook part, we're referencing, notice that this is spelled exactly the same as this. Those have to be exact because that is the blueprint's name, that's the class's name. So when we say new gradebook, we're essentially invoking that, and we're saying we want a new one of these things. And by the way, we're going to call it my gradebook. So that's the name of that unique object. So again, back to our original analogy with like cars, we would say something like car, Ben's car equals new car. And then that's the specific car that's associated to me. That's my car that I've created in Maine. Or Bob's car or whatever. This is the name, this my gradebook. That's the name that we give it, and we can give it any name we want here. Of course, if you give it any name you want, like say we call it Bob's gradebook, then we also have to change this line to Bob's gradebook.displayMessage because this is how we're going to refer to it in the rest of the code. So if we change it here, we also have to change it here. But now the important part is this is also calling displayMessage, so it's calling a method called displayMessage. And now finally this is an application that does something. It doesn't do very much. It just spits out a message at the prompt saying welcome to the gradebook. That's all it does. But at least it's doing something. So it spits it out and that's that. Yeah. Would you always see the other class twice in the assignment line? Yes, I see what you're saying. You're saying, would you always see this and then this? In our, there are exceptions to that once you get into inheritance, and especially in things like C++. But for this entire class, this is how, for like all of 256, this is how you will see it. It'll be, the name of that class will appear twice. And I think that's about all I want to say about that, because if I start talking about exceptions to that, it's going to kind of confuse things. There are exceptions to that, just so you realize, but for this class, for 256, you can expect that's what you're going to see. So now that we've got that, one thing we need to realize is that, notice that I've got this special thing called public static void main. Well, what Deitel and Deitel talk about next is they talk about the static method and how that's unique. This part here is a little bit confusing in that the whole time I'm telling you, well, all a blueprint really does is it just defines something, but already I'm throwing some exceptions in here. Static is one such exception, because when you have a static method, it actually shares that method with the entire blueprint. So what that means is we will only ever have one main, all right? So I could have put this static void main inside of gradebook, and then that becomes an application, but instead I put it in gradebook test in the driver. This driver could have other classes, is my point. And so the next, and they're just talking about that just because it's there, just so you, and if you don't, the thing about it is that this public static void main, this static word, don't let it confuse you for now. You need it when you define main, and then later we'll get back to it and we'll talk about the difference of putting the static word there. Notice we didn't have to put it there when I said, here's my example from gradebook. I'm talking about add student. We also didn't have to put it here. We just said public void display message. Those are normal methods. All right, that's a normal method. You would just call it a method. You wouldn't call it a static method. Whereas this is what we call a static method. And so it's got some uniqueness to it in that there will only ever be one main. It basically says, if I'm going to be a static method, that is the one case of that method I will ever have. Whereas if you're not a static method, each new gradebook you create has its own display message. Each new car you create has its new add seat. Each new gradebook you have has its own add student. It's got a shared definition of it, but it's got its own case of it. Then what we do next is we declare that variable of that class type, and this is the part where we were talking about, you're going to see the name of the class type equals, and then new, and then the name of the class type again. So other things to analyze about this are the parentheses. The parentheses on that, after that new, so we say new, the name of the class, and then parentheses. So here we say new gradebook, left parentheses, right parentheses. That part's important. The reason it's important is because actually what this really does behind the scenes is it calls a method that happens to be a unique method called a constructor. Oops, I'm going the wrong way. The constructor is like a method, but it's only used, and it's exclusively used whenever you call new on something. And the reason they did that is because they want you to be able to pass in something just as you would to a normal method. So let's say that we're going to call, well, not add student, but let's say we're going to set up a new gradebook. So we've got our gradebook.java, and we've got class. Let's get rid of this stuff for a second. So we've got like class gradebook. And we've got a public void display message. Well, all of these can optionally take parameters inside of here. And also, by the way, maybe this has something called a private, we'll get to this in a second, but private int class size. I'm getting a little bit ahead of myself, but I think not too bad to sort of help explain it. This class size, if gradebooks only can have 30 people in them or something like that, that's why we want a constructor, so that inside of that new, we would be able to do something like um, gradebook cs256 equals new gradebook of maybe 30 students. Then what happens is this 30, and I haven't told you how yet, but the point of that is so that 30 can go into the class size in the gradebook. So it's like you're calling it with a parameter. You're calling the constructor with a parameter. They wanted it to basically be, yeah, they wanted it to basically be like it's a method like any other method. So that's really what the point is here, and that's why you see the parentheses there. So here we've got parentheses, and so that'll come into play later. And if that doesn't make total sense yet, that's okay. But for now, you just need to know that you have to put them after a new call, and we'll get to the parameters in a little bit. Now, to call a method, you use the dot separator. So for example, we say dot display message. We could say cs256 dot display message. And that'll dump out to the screen my message that I put inside of display message, like welcome to cs256 or something like that, whatever I put in there. Don't worry too much about this. This tells you how to do this on the command line. We're using Eclipse instead of the command line, so you don't need to worry about that. All right, so one of the things, this is, this is Intro to Software Design. This isn't strictly just Intro to Java, although it is that too, but we do more than just that. One of the things we talk about in here are UML class diagrams, and we're going to introduce it right here. So basically, UML stands for Unified Modeling Language, and it's basically a pictorial form of how the classes are organized underneath. So with boxes and lines and that kind of thing, you can draw these classes out. In this case, a class diagram is going to be a rectangle, and it's going to have 3 different compartments. One is the class name itself, that's going to be centered horizontally in boldface. Middle is going to be the class's attributes. Those are the instance variables that we talk about in section 3.5. And then the bottom is going to be the class's operations, which are the actual methods. That's like the behaviors that I've talked about before. So for example, gradebook just has one method. It doesn't have any instance variables. I added one to gradebook here. This int class size that I added would show up right there. But as Deitel and Deitel have explained it so far, it doesn't add that, so it just has a display message. So the next thing we want to talk about here is basically declaring a method with a parameter, and you'll need this for the labs, I believe. I have to check that in a second to see make sure you've got enough to go on for the labs before I pause the lecture here. So basically, using our car analogy, you can think about the fact that when we want the car to move, we need to actually tell it how fast to go. Farther down we press the pedal, the faster the car accelerates. What we're really doing there is we're sending a message to the car. We're telling it how much we're pushing down the throttle and therefore how fast it should go. That's what we call a parameter. So parameters go into the methods in a comma-separated parameter list, it's called. Method calls supply those values to the method when it's called, and that's what we call passing our arguments into the method. So for example, here we've got a display message string course name, and we say welcome to the gradebook for, and then course name. This is similar to printf stuff that you've done before, where we just then print out the course name. So from my main method, I'm going to call display message, but this time I'm going to do what's called passing in an argument. I'm going to pass in the name of the course as a string. And this is how that looks. Well, first of all, this is reading a string from user input, which is important to get used to. This part here, scanner input equals new scanner in. We'll talk more about that, but basically you just need to know that if you want to read input, you need to do this, then create a new scanner input, and then you can say input.nextLine. And of course, where we're going with that is then we want to call mygradebook.displayMessage name of course. So whatever you've typed in here is going to be displayed back to you here, because this name of course is passed into this method, and then that method does what we just talked about. It says welcome to the course, and then adds on a string. So make sure that when you're doing this, your methods, your arguments in your method that you've defined should match up to the number of parameters from where you're calling it. So wherever you're calling it has to have the same number of parameters as you defined it as. So in our case, we had one parameter, which was a string, and we're calling it with one parameter. If there's two, you need to call it with two. Here's the new UML for this. So we modify the UML to include now a string. As I said, we'll get back into this import stuff, but basically for now you just need to know that that is how you have to do a system or a scanner in. I used to go over this a little more fully at this stage of the course, but I found it to be a little confusing. We will go over the import stuff later. For now, if you want to do a read in, you need to use this import. All right, let me double check something quick before we go on. Okay, so we do need to do a couple more things here in order for you to do your labs. Okay, so we definitely need to cover this, and then I think that, let me see how far we need to get. I just want to make sure you have time to do the labs. Yep. Okay, so section 3.4, basically. So I already touched on this. I added a what's called a local variable to the gradebook here. These are variables that are defined inside the, or I'm sorry, this is an instance variable. Now this is talking about local variables. I probably was just confusing there. Local variables are different. Local variables are different than instance variables. Instance variables is what I led with. So let me start with instance variables and we'll go back to local. So this is what's called an instance variable. Okay. It is an instance variable because the class is going to maintain its copy of that particular thing. So like each gradebook is going to have a class size. Like for example, CS classes are locked to 25 people, even though we usually wave in a couple. So gradebooks might, for CS classes, might be 30 people, but you know, you've got a calc class, I think usually they're capped at 50 or something, 40, somewhere in there. So each instance of the class, like cs2569 is going to have 30, calc 202 or whatever it is going to have 40. You know, each one is going to have a different number in that instance variable. That is different from, let's say, kind of like last time when we were playing around, we talked about variables. Let's say that I've got inside of this display message, I've just want to declare an x equal to 2. And then, I don't know, I do something with that 2. I'm not sure what, but this is a local variable. This local variable only can be accessed inside of this method. Local variables immediately do what, and we'll get to this later, but they do what's called go out of scope at the end of this bracket, and it can't be used anymore. whereas an instance variable can be used anywhere inside of here. So I could say, like, for example, I could say x equals class size plus x or something like that, and that's going to have the effect of adding 2 to the size of the class. So we call these things, I'm going to go back now to locals. So these are just declared inside of a body of some sort of, opening curly bracket and closing curly bracket. And they're just lost after that method terminates. And then the difference with instance variables is they stick around. Sometimes we call these things fields as well. So like this instance variable, this is in what we call the fields of the gradebook. This might also have a private string course name. So those are the fields of the class. So for example, here we've got a string course name. Now here's a method that's called setCourseName. And we say course name equals name. So this is interesting because here course name needs to get set, right? And I haven't talked about constructors yet, but eventually we're going to use constructors to set those. For now, we can just do it with a method. Methods can take parameters and they can assign parameters. They can assign instance variables specifically. So this is assigning the instance variable course name is going to be whatever is passed into set course name. Remember, we also talked about returning things. Here's where we actually do one for the first time. This is saying get course name, return course name. It's sending back whatever was set. And then we've got a display message that's calling get course name. So welcome to gradebook for get course name. So it goes down here, and so it's using course name. It's going to say welcome to the gradebook for whatever you call set on. So over here where we call set course name, so notice initial course name is blah. That's going to print out the course name here. That's how the printf works. This is going to be empty because we haven't set it to anything. Then we do a read in. We set it to some name that the user types in. Then we print it again. So this is expected behavior. We would say, please enter the course name CS1 101 Introduction to Java Programming. So the initial one is null, so it has nothing. Then we type this in, then we call it again, and it's in there. So this is doing a couple things. It's populating instance variables for us, and then it's printing it out. So every field has a default initial value that Java sets. Default value for string is null, and that's why it ends up printing null out there. So like, for example, the default value for an int is 0. Bools are false. Strings are null. Of course, it's normally considered bad practice to use those instance variables before you actually declare them. So that's why we'll talk about constructors and how it's important to set some initial value in the constructor. But that's down the line. So for now, you would call set course name if you want to access those instance variables, and you would set it to some user specified course name. Here's where we get into what we're doing in lab today. So set and get methods. This happens so often in programming that some of the newer languages like C# added a very quick way to do setters and getters. They call them like accessors, basically. And there's a very quick way to do it in C#. You'll see when you make a new class, let's say we're making a new class here like we've got. This is the normal pattern you're going to want. for every private instance variable you make, you're probably going to have a set and a get for that private variable. Because odds are you're going to want to set it at some point. Odds are you're going to want to get it at some point. So you might as well get in the habit of making a setter and a getter for that thing. It does not break object hiding, which was one of the principles of object-oriented design. It might seem like, well, if I'm going to do that, a lot of people will criticize it and say, well, if I'm going to do that, I might as well make this public. By the way, you can do that. You can make your instance variables public, and then everyone can set it. Now, that's considered bad, because what that means is there's no central point where that course name is being set. Here, this provides one central repository, one central place that the course name can be set. So think about it from my earlier example with some of the stuff I've been working on my contract job, which is the drone stuff. Let's say we've got recovery. That's one of my tasks that I was working on. There's a certain altitude that these things need to go before recovery can be achieved. The reason is because if the drone dips down, if the tree line is up here and the drone dips down here, then it has to come up here before so it can clear that tree line. So that's a very important variable to set. And so if anyone else is setting that and tampering with it, if I make that public, in other words, anyone could just come along and just wipe that out. If I instead make it private and put a public accessor for it, like a setter, what I can do then, this is kind of, again, down the line, what I can do is I can put what's called a breakpoint here, and I can see everyone that's calling it very easily, and I can know if anyone is actually trying to tamper with it. If I don't do that, then I still can test that tampering, but it makes it much more complicated. It's going to save you a lot of time to have these setters and getters down the line if you're trying to look for potential problems, debugging, potential security hacks, stuff like that. So it's good secure coding methodologies. And that's why I say data hiding. We're not breaking data hiding when we say add me a setter and a getter. We're encouraging data hiding, actually. This is one of the core principles of object-oriented design, is data hiding. And it's for that reason. If I'm setting altitude on a drone, I don't want that altitude parameter to be visible to everyone. I want to be able to control that parameter exclusively. Now maybe there's other people that certain people are allowed to set it, like the panel that sets it, maybe the GUI panel maybe can set it. The operator on the ground that has a remote control can maybe set it. I'm going to dish out access. I'm going to give permission to those various locations where I think it's okay to set the altitude, as opposed to just saying a blanket statement of just saying everyone can set it. It's kind of the difference of having a user on your Windows account or not. Some people have Windows machines and they don't have a user on it or a password. It's just open, right? But if you provide a user password system, you can define who has access to your PC. Okay, I'm going to let Joe have access to read and write on everything, but Mary can't install stuff, for example. So you control the access at that point. And that's what we call data hiding. So it's a very important part of object-oriented design. So we covered that, So the clients of these objects are going to be, for example, the driver. This is going to call the sets, the gets. This calls display message in this case. This would call set course name. This would do all of, it would call set and get, basically. And this is now the new UML for that. We had setters and we had getters. Set course name takes in a string, sets the course name. Get course name is called, it takes the course name and sends that back out to someone. So that's about good. My usual runtime is about 45 minutes or so, so I think we're about good. Let me show you quickly what you're doing for lab. Lab 4, we're going to use an account class that's going to have debiting from that account. And then what you'll need to do is define so this is balance equals balance plus amount. That defines the addition. Oh, you're not seeing this. I'm sorry. Let me drag this over. This is the class account that we're going to modify. So we're going to make a debit field, or a debit method rather, with the return type of void. In that sense, so right now, for example, there's a credit, but there's no debit. So when you're done with this, you'll be able to, for example, enter a withdrawal amount. And then what I'm going to ask you to do is two things. You have to make the debit actually in the blueprint in the account class. Then in the driver, this is the first time you'll have a driver, because notice this is called the count test. You'll do something like, account one dot withdrawal of some amount, and that amount is this amount that's from the user. So you have to do two things. You have to make the debit in the first place, and then you actually have to use it. And the rest of that description is in there, but basically it tells you right here. So you use the parameter to enable the program to specify the amount the user wishes to withdraw. We are going to do a simple if test here to test whether the withdrawal amount is more than the balance. If it is, then we would display a message. Otherwise, we would just simply withdraw from it, and we should be good to go from there. So fairly straightforward, but as always, just let me know if you got any questions. So I'm going to stop recording now. That's lab 4, I think I've got on there. Yeah, lab 4. So Dropbox should be open, and let me know if you got questions.